name's Drew Barbier, Senior Director of Product Marketing at Sci5, and happy to be a part of 2021's RISC-V Taipei Day. Today, I'm here to tell you how Sci5 is delivering on the promise of industry-leading RISC-V processors with the recent release of the Sci5 Performance P550 and P270. The market as we see it's in the middle of a transformation with many different factors at play. There's been hypergrowth in embedded endpoints, and that the expansion of AI from the data center to the edge is disrupting old assumptions and shifting our industry away from traditional computing. Tomorrow's compute requirements demand higher levels of performance wherever that compute happens. These requirements demand more specialized solutions that are highly optimized, domain-specific, and workload-tuned. This dynamic is opening the door for new computing alternatives that can deliver optimized value to efficiently solve very specific compute challenges. And RISC-V and Sci5 specifically are well positioned to capitalize. For RISC-V to become great, we must capture the nucleus of major compute platforms in our industry. At Sci5, we're already participating in most of these compute platforms with our RISC-V-based embedded solutions. But now we need to deliver higher performance, which is needed to capture the heart of these systems. Every one of the major compute domains is going through their own upheaval right now, and every one of them needs highly optimized solutions to move the market forward. Automotive needs functional safety to realize the path to autonomous driving. 5G and Open RAN need parallelized compute to realize the ubiquitous communication. Mobile and endpoint devices need increasingly better performance per watt, and the data center always requires more compute density. It's wherever computing happens that RISC-V is poised to deliver for the next generation, and with its solid architectural foundation and the established RISC-V ecosystem thanks in part to RISC-V International. And you couple this with the flexibility to extend into more specialized compute platforms. And this is the key to RISC-V's success and what will make it ubiquitous. And at Sci5, we're ready to take on these challenges. And so today, I'd like to tell you about Sci5 Performance family. Sci5 and the industry's highest performance application processors built on top of RISC-V. With the arrival of the Performance family, we've introduced two new products that showcase Sci5's capabilities, and these are the culmination of over 2 years of development by our engineering teams. Sci5 Performance is the realization of our strategy to bring high performance, high value, differentiated products to market. We have two exciting products in the Performance family. The P550 is a 13-stage, triple-issue, out-of-order processor and is the highest performance RISC-V processor you can license on the market. The P270 strikes a balance between control processing and compute with an efficient 8-stage, dual-issue, in-order, scalar pipeline along with a 256-bit vector unit. Both products are released to production today and have been delivered to lead customers. So now let's take a look at the P550 in more detail. The P550 implements the RV64 GBC instruction set. This is the general purpose instruction set plus bit manipulation and compressed extensions. The bit manipulation instructions add instruction level support for common bitwise operations, which, in general purpose code, lead to better performance and code density. The compressed extension adds support for RISC-V 16-bit instructions, giving class-leading code density when compared to other legacy 64-bit architectures. The C extension directly results in better instruction cache utilization and the resulting higher performance that comes with it. The P550 implements the RISC-V SV48 virtual memory architecture, which makes it suitable for scale-out applications that require large memory footprints of up to 47 physical address bits. However, Thanks to the flexibility of SiFive's implementation, each P550 delivered is tuned to only implement the necessary address bits for a given customer design, thereby saving power and area. In terms of the memory subsystem, the P550 has 32 kilobytes of L1 instruction and data caches. And new to SiFive, we're also introducing a private L2 cache on the P550. In addition to the private L2 cache, the P550 also has sophisticated prefetching that allows it to prefetch into either the L1, the L2, or the L3 cache. Taken together, the P550 has great memory performance, and all of the memories in the core complex are ECC protected. And, as with all SiFive cache-based processors, the P550 supports multi-core implementations with up to 4 cores in a core complex. The P550 can be configured with the SiFive Shield hardware crypto accelerator to help speed up cryptography functions like AES and SHA. And finally, tying it all together is SiFive Insight Trace and Debug, which gives our customers access to the most advanced debug capabilities on RISC-V with broad ecosystem support. Now, if we dive a little bit deeper into the microarchitecture details of the P550, at the front end of the pipeline, we have the ability to decode up to 3 instructions per cycle, coupled with a very unique reorder buffer which allows us to encode up to 7 instructions per entry. At 56 total entries, we found that this ability to encode multiple instructions per reorder buffer entry allows us to have a sizable reorder buffer while at the same time saving significant area. The P550 has 3 integer ALUs and 2 floating point pipelines, each with its own issue queue. So what does all this translate into? Well, it translates into significant performance density, up to 3 times that of competing designs like the ARM Cortex-A75. We're using SpecInt and Spec FP 2006 suite of benchmarks as the metrics by which we measure SiFive performance cores. Spec 2006 gives us a sizable set of benchmarks that are representative of real-world applications while still being something our design and performance teams can run in pre-silicon environments. And most importantly, these benchmarks are understood and meaningful to SiFive performance customers, as opposed to a benchmark like Drystone or CoreMark, which are small, easily optimized, and not necessarily representative of code bases that are expected to run on complex application processors. Now, back to the P550, we're able to achieve an incredible SpecInt 2K6 score of 8.65 per gigahertz and 9.4 Spec FP per gigahertz. Both of these are significantly higher than that of the measured Cortex-A75 scores. And in the case of SpecInt, we're looking at 35% higher performance. The most amazing part of all of this is that we're able to do this in just 0.38 millimeters squared for the P550 core, including both the L1 and the private L2 cache RAMs. Taking all of this into account, we're less than half the area of the Cortex-A75. This really speaks to the strength of RISC-V and what it can do with a high-performance implementation. Now, if we shift to the SiFive Performance P270, the P270 shares a lot of the same architectural features as the P550, but with a few notable additions. Most significantly is the RISC-V vector ISA support. The P270 is compatible with version 1.0 release of the RISC-V vector specification. This makes the P270 a balanced implementation capable of both control and compute functions, which make it suitable for a large range of applications like image processing and manipulation, audio processing, sensor fusion, industrial control, robotics, and more. And just like the P550, the P270 also supports multi-core coherency with up to 4 cores and has a similar memory subsystem with private L2 cache. The P270 also supports Sci5 Insight Trace and Debug, as well as the Sci5 Shield hardware crypto accelerator. Looking closer at the P270 implementation, the Scalar pipeline is an 8-stage dual-issue design, while the Vector pipeline is a decoupled 9-stage implementation. The Vector unit has a hardware vector length, or VLEN, of 256 bits, meaning the vector registers are 256 bits wide, and they support elements of up to 64 bits wide. The P270 vector unit supports a range of different vector data types, including both integer and floating point. In floating point specifically, it supports half, single, and double precision data types. And to keep the vector unit fed, its data path has a dedicated 128-bit per cycle path directly into the private L2 cache, allowing for the vector unit to keep up with the most demanding data sets. So if we look at the P270 SpecInt 2006 performance, it bests that of a high-performance ARM Cortex-A55 implementation by over 20%, achieving a geo-mean score of 4.6 per gigahertz and a spec FP score of 3.4 per gigahertz. And the P270, even with the vector unit, is able to achieve these scores while consuming very little silicon area at just 0.3 millimeters squared, including the core, the vector unit, and the L1 and L2 cache RAMs. The P270 simply allows our customers to pack their designs with an incredible amount of compute density. Now, despite being higher performance than industry equivalents already, we actually have room to improve on these scores, as the tools that we use to achieve them don't yet leverage the RISC-V vector capabilities of the 270. So let's spend the next couple of slides learning more about the tools Sci5 are offering to enable our P270 customers. Let's start with the Sci5 tool suite, which is free and available now and includes support for RISC-V vectors. The Sci5 tool suite brings with it both GCC and LLVM compilers. The LLVM compiler is particularly interesting for the P270 as it now includes support for RISC-V vectors, including intrinsics as well as auto-vectorization. The auto-vectorization is able to take C code, like the Saxby multiply accumulate function on the slide, and produce RISC-V vector code. Now this is an early version of auto-vectorization support, and there's still a lot of room for improvement, but it's a start and a very low effort way of realizing more of the P270's potential. The LLVM compiler also has full support for RISC-V vector intrinsics. The intrinsics allow application programmers to map low-level functions more easily onto RISC-V vectors without having to drop down into assembly. We expect most developers to use the vector intrinsics to tune their applications for RISC-V vectors. In the example on the slide, the C code on the left was rewritten using the RISC-V vector intrinsics, and the result was a higher performance and more efficient implementation. And speaking of vector intrinsics, if you happen to be migrating to the P270 from some other architecture, we now have a tool called Sci5 Recode to help make that transition as seamless as possible. Sci5 Recode translates C intrinsics for other SIMD and vector architectures into RISC-V vector code. This allows customers with legacy code bases to very quickly migrate to RISC-V and leverage the vector compute capabilities of the P270. Sci5 Recode is included in the Sci5 tool suite and today supports most ARM Neon intrinsics. And using Sci5 Recode couldn't be easier, as it is as simple as passing a compiler option to the Sci5 LLVM compiler. And at Sci5, we believe in what we call relentless innovation. I've had many talks in the past about Sci5's update releases, and all of the new products and features and capabilities that we've brought to our portfolio over the years. This relentless innovation doesn't stop today, and we're continuing to march faster than ever to bring our customers and the market the best products, bar none. Today, I've talked about the Sci-5 Performance brand and its first two products, the P550 and the P270. As we approach the end of the year, we're looking to bring Sci-5 WorldGuard system security and higher core count offerings to these products. And looking even further into the future, into 2022, we are looking to bring RISC-V vector compute support to the P500, hardware virtualization support to the entire performance portfolio, and of course, as always, to bring the next generation of high-performance RISC-V vector processors to the market. There's an incredible market opportunity for Sci-5 across our portfolio. We've had recent announcements from Intel, who selected the P550 for their Horse Creek platform, to Tenstorrent, who selected our X280 for their next generation AI and inference processor, to Renesas, who announced a partnership with Sci-5 to develop next generation high-end RISC-V solutions. Sci-5 is the undisputed leader in RISC-V, and performance, intelligence, and essential are the brands at the heart of Sci-5. The Sci-5 Performance P550 and P270 are available now and that includes evaluation models and FPGA enablement platforms. Please contact us if you're interested in learning more about the Sci-5 Performance products or any other Sci-5 product. Thank you.